only because there's a nice, really easy way of conceptualizing this. It doesn't look like it would be nice and easy, but it actually is. Right? So absolute value function graphs work the same way as absolute values themselves work. Basically saying it could never be negative. All right, it can be zero. Zero is fine, but it can never be negative. All right. So what I'm going to do is I'm going to graph y equals x. So as if the absolute values were not there. All right. So we're going to start with that. So y equals x would be this set of points. Yeah. I was debating whether to go with the line draw tool, but I always screw it up, so I'm not even going to bother. All right, I'm not going to create a solid line here because this is actually not going to be entirely what I want, but I'm just going to get a sense of where it would be. This is the line y equals x. All right. To get the absolute value graph, make the negative part positive. We're using symbols, so why not? Make the negative part positive, aka, so meaning, reflect negative part over the x-axis. So we'll have to talk about what I mean by the negative part, but that at least gets you moving in the right direction. That was a poor quality C, so I'm fixing that. All right, so reflect the negative part over the x-axis. So make the negative part positive. The positive part stays positive. Zero stays zero. Anything that's on the x-axis is fine. All right, so I got a part of this graph that's going to stay exactly the way it is. This part right here is fine, and then everything in this neck of the woods. All I'm going to do is take the part of the graph that was negative and reflect it over the x-axis. What does that mean? Count how many boxes it is away from the x-axis. 1, go that number of units in the opposite direction. So I'll have a point here, 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 here. That is your graph of y equals the absolute value of x. That whole shebang, that whole V-shaped graph. So if you know how to graph a line, you know how to graph an absolute value function. That's great news. Because you don't even need a calculator to graph a line. I'll show you how to do it on a calculator in a little bit, but I mean, that's pretty straightforward. The good news is, or the best news, is that it doesn't just work for lines. If I find the absolute value of a parabola, or maybe a trig function when we learn about those down the line, logs, exponent, fancy math words. Anything that's not a line or a parabola, something more complicated, something very curvy, you can still do the same thing. The key is knowing where it crosses the x-axis, like the x-intercepts, also known as the roots or the zeros, aka the focus of the last 2 units. Right? So we're still building off of the stuff that we previously learned. The idea being that you would set your equation equal to 0 and solve, figure out where it crosses the x-axis, or if it's just a simple linear function, you could possibly eyeball it. In this case, you could, but if it's something fractional, maybe not. Right? So, but you definitely want to keep an eye on it. We learned about transformations in quadratics. The great news is, more great news, everything's great news, is that it works the same way. The transformations work the same way for absolute value functions as they do for parabolas. So if you took the time to get to know the relationships for parabolas, for quadratics, then you already know what you need to know for absolutes. So if I tell you that the standard form for an absolute value function is f of x equals a times the absolute value of x minus h plus k, you got everything you need. Right? Because h and k would represent the what? Vertex. So now I would know where my parabola, you see? That's how similar they are. You know, you could easily get the terms confused. Now I know where my absolute value function is going to turn around. And a, just like in a linear function, would represent the slope. A is the slope. Now, if a is positive, we have two possibilities. A is positive or A is negative. Well, what would happen in a parabola if the A value is positive? Opens upward. All right, so our absolute value function will open upwards. And in a parabola, if the A value is negative, it would open downwards. So the absolute value function in this context would open downwards. All right. So really, my only role in this unit is to just connect all the stuff you already know to this new form of a function, right? But really, when you think about it, you don't really need me for too much, at least not yet, all right? Because in A, it says, how do you think a graph will compare to the parent function? All right, well, what is the plus 4 going to do? Shift up 4 units. All right, what about B? Reflect over the x-axis. Stretch factor of 3. And D? Shift right 2 units. All right, so this stuff you could label up on your own now, because I already just kind of stole my own thunder. I might as well do it, I guess. I'm right here. Negative, opens, down. Any value is a slope. H value is your axis of symmetry. HK is the vertex. The K value represents the max or min height. And again, you do know that, I mean, you just burned right through it, that it's talking about stretch and shrink and shifting left and right and up and down. But when you get into word problems and things like that, you're talking about like an object is launched into the air, how high is it going to go? Is it going to be a max? Is it going to be a min? Things like that. You need to know these things also. All right. So, not too bad. So the next little section is asking you to write the equation, but I know you can handle that. What I want to do is jump down to number 5 and show you how to write the formula for the equation of the absolute value function. All right, so I'll write the equation itself. It's like Regent's words. I just can't live with it. Write the equation of the function depicted by each graph. Somebody can have that. All right, the formula itself is f of x equals a times x minus h plus k. All right, so find the vertex. In this case, it's what? -2, -4. And I need the slope. All right, so I need a little rise over run action here. 1/1 seems reasonable. Looks like it's hitting every corner. Just be careful. Sometimes it gets really close, but not quite. If you go up 1/1, though, in this case, box by box, because it's a scaled graph, you're really going up half a unit over half a unit. Sometimes, and just be mindful of this, sometimes the x-axis can be scaled one way and the y-axis can be scaled in a different way. So you may have to pay careful attention to that. So what I do is I tend to lock on to values that I know and then actually compute the slope just to be sure. So what's this coordinate here, the one I just marked off? 0, -2. And so if I were to find the slope of the line segment connecting those 2 points, it would be change in y over to change in x. So in this case, you're going to get 2/2, which is 1. All right, so that's just an algebraic way of showing, computational way of showing it. It helps you to avoid having to rely on the grid, first of all, being visible. Sometimes on the regions, they don't even give you a grid. Like they'll plot a graph and it'll be just on white paper. And you'll have to rely on the coordinates because you won't be able to count boxes. All right, so you gotta be prepared for pretty much any way. Quick question, when I'm finding the slope between 2 points on a curve or on a line, in this case, what's another name for that? Went back to the last unit.
Rate of change.
Rate of change, average rate of change is what we're looking for. So later on, in calculus, you'll explore that more, but that's a term you want to be familiar with. So whenever you see rate of change, you want to be thinking slope. All right. Sometimes that means slope formula. Anyway, so this gives me the absolute A. So this is the absolute value of A. All right. It doesn't, because I could have picked a point over here and come up with a completely different slope. If I picked 2 points over here, I would have come up with a slope of -1. That doesn't mean I put in -1 in for A. So what I have now is the numerical value for A. All right. So that's going to be a 1. I'll chuck that in there. X minus the -2, which we'll clean up in a sec. You can skip the step if you want. Plus a -4. But what I'm going to do is I'm going to put a little plus sign here just for note-taking purposes today. That plus sign is coming from what? It has nothing to do with the slope. It has to do with not stretch or shrink.
Absolute value.
It's along the lines of minimum or maximum. It has to do with orientation. The fact that this absolute value graph is opening upward gives that a positive sign. So opens up. All right? Because I could do all this slope work here, get an answer, but if this thing opens downward, I got to slap a negative sign on the front of it because it should be negative because it would have a maximum vertex. All right? So my final answer in its cleanest form would be y equals just x plus 2 minus 4. All right? It's our first one doing it, first time we're doing something like this together, so I'm showing a little bit more detail than I really need to, but it's for the best. Generally, I'm just looking for the answer. So you get the right answer, you're fine. But these little details in there lead to the understanding that allows you to get the answer right. All right, and especially when it comes to multiple choice questions, because we know moving forward that's where we gotta pay careful attention. You make a minor mistake, On a free response question, you lose a point, half a point. You make a minor mistake on a multiple choice question, you lose credit for the whole thing, right? So you got to be really careful. What do you do after you've come up with your equation? You haven't read my intention yet. Yeah, graph it. I'm walking over here. Graph it. See if your graph jives with the picture.